Now next is Thyristor SCR, we call it, the controllable one-way valve, adding the gate control. Now we got the control, but limited control. We will see. See, this is the same what is diode, but it has only gate added. Same symbol, only gate is added. Here now construction is important. PN, this is our diode. Another P is added, small P region, and N is there. So here we have got three terminals. One is C, E, and gate. Okay. So anode, cathode, and gate. Now, this is anode, this is cathode. This PN represents our original diode. Then this thing is added, PN. So another diode is overlapped. Now we know how it conducts. Diode, how it conducts. Now I will show you again. See, on this depletion layer, everything is dependent on this depletion layer. If we add in this minus, if we add some positive signal or current or plus holes, what will happen? This barrier will be conducting easily. This will conduct. In the same way, what will happen if we add positrons here through gate? Means some current we will put it to gate and emitter. Between this current will be applied. Then this barrier, PN barrier, will become weak. Just now I have shown. Okay. If we add more positrons, what will happen? This will become stronger and this will start flowing current through this diode. Okay. So this is a diode and this gate is added. And when this gate opens, whenever you are putting some current through this gate, that time this entire thing will flow from E to C. Okay. Now see the revolutionary addition. This gate is revolutionary addition, gate terminal. How it works? Three operating states. First is blocking. Gate is equal to no signal. If there is no signal, it will not conduct. Okay, it will act as a barrier, that P part. Forward voltage applied, but stays off. It is same diode, but what is happening? We have added another diode which is not conducting, two diodes kind of. Just for the concept I am telling you. Now, but stays off, waiting for gate signal. This is a key difference from diode. It is waiting. Though voltage is applied, it is not fired, it is not conducting. Now conducting, gate is equal to, gate is triggered. Small gate pulse 50 to 200 milliampere is sent through gate, in between gate and emitter. What will happen? Device latches on within microseconds. Within microseconds, this is very fast. I have told you, positrons are added in P region and that becomes weak and the gate will open. Okay, but it is required, that barrier is, to break that barrier, this much current is required. Once that barrier is conducting or this is open, then it will stay on even after gate is removed. The current path has got its way and it will go through, though you have removed the gate signal or gate current. So conducts like a diode now. It is a diode now. But it, to start the current, it needs a trigger current, that is 50 to 200 milliampere. Turning off, cannot turn off on command. Okay, it is not possible to turn it off. Only turns off when current naturally drops to 0. Must wait for AC cycle 0 crossing. Once AC cycle is crossing 0, what is happening? Current becomes 0 and then it will stop, it will not conduct again. Again we need to apply the gate signal or this current and then again it will conduct. So from 0 it will not start automatically, but we don't have control because in between you cannot stop. It need to go to 0. Okay, now I will just show you the waveform, how it conducts. See alpha, this angle, whatever angle we provide it to gate. See, what is firing angle? When to start? If it should start at 0, it should start at 30, 60, when our gate pulse is given 50 milliampere or 150 milliampere, whatever, is given to the gate. So that is the angle. At what angle? Here, here, or where? Okay. So if you fire it at 0, it will conduct full cycle from 0 to 90 to 180. Okay. So fire at 0, full 180. Thyristor will conduct for full 180. Maximum power will be delivered. Output will be maximum 100%. Now, if alpha is at 30% we have triggered. Then fire early in cycle, thyristor conducts for 150 degree. Okay. So 30 will be minus from this 180. So it will conduct for 150. So 95% power, whatever is input, 90% power is passed. Think in terms of energy or power, I told you. So 95% energy will be passed through our thyristor. Now if it is triggered at 60%, what will happen? 180 minus 60, it will be 75% power will be passed through. Here you can see, from here it is triggered, and this much, this shaded region is power. The amount of power is passed through thyristor. 90 degree peak, it will be only 50%. From here it will be only 50% power will be passed through. So that is how we can control when to start, how much power in one's half cycle should be gone ahead. So that is the control we have got from this thyristor. Okay, so we have already seen the control magic. Phase angle is equal to voltage regulation. Now we can control the voltage level. See, early firing at 30 degree, if alpha will be 30 degree, then what will happen? 95% high voltage output, 95% voltage will be applied. If late firing, then only 25% voltage will be applied. We have seen how it happens. Now a real example, utility voltage drops from 450 volt. Before this, what used to happen? If utility voltage drops down, there was a problem. Then what happens? 380 volt. Now control circuit fires thyristor early. It will fire it early at 5 degree. Okay. Then what will happen? DC output stays constant at 540 volt. If you fire it at early, then the voltage level will be higher. Okay, we have seen at 30 it is 95%, at 120 it is 25%, at 5% it will be higher. Okay, so in this way you are controlling the voltage regulation is possible. So the limitation cannot turn off on command. Turning off is not possible, cannot create high quality inverter waveforms. High quality inverter waveforms is not possible. We will see how IGBT is the next level. These problems, limitations are overcome by introduction of IGBT with pulse width modulation, okay, with PWM. So maximum switching is approximately 400 times per second. It is also not that fast. 400%, 100 times is faster, but not fastest. Okay. So result, modified sine wave within 20 to 30% distortion. 20 to 30% distortion, which is not as a ideal sine wave. Okay.